Hi everybody, I hope you're all well. As you know, I'm doing really good, so I hope you are all fitting well too. Right, a little letter from Norman for John. It was from Norman Harrison, but he sent us a little gift as well. So Norman, thank you very, very much. And we have a guardian angel. She comforts you both day and night, always keeping you in her sight. Wherever you go, whatever you do, your guardian angel watches over you. That's lovely. Thank you very much, Norman. Take care. Bye.
It's a package arrived in the post last week from a gentleman called Norman Harrison. I've spoken to Norman a few times on the MIG Welding forum. Norman just bought a second-hand box fad lathe and he sent us these which came with the lathe. He wasn't sure what they are, what they're for. I'm sure these are for like a die head for cutting threads. 5/8 DNF on there. There's another one there, 5/16 by 18. So they're probably for thread cutting. I'm not sure what these are for. And these two pieces here, they've been really accurately ground. They stick together, the finish on them is that good. I've got no idea what they're for. Possibly some sort of tool holder. That could well be a cutter, like a profile cutter or a threading cutter for cutting threads. I just don't know. There's another one there. If anybody can use these or knows what they're for, give us a shout. I'll willingly post them today because I won't use them rather than use them for probably packing pieces in spacers. I mean, they'll make good parallels for the milling machine, but it seems a waste if somebody actually knows what they're for and use them, because these items do look expensive. Norman also sent a little package for Debs. I'm going to let her open that. Anyway, Norman, thanks very much, and I hope you enjoy your box fad. All I want to do is square the rough ends up and something put it in a vase. Right, that's the end squared up, quite a nice finish. Some really nasty sharp edges on there, we need to take them off. I've got a special tool for doing that. That's a special tool, simply a 6-inch file, gently. All 4 corners. You can do this in a milling machine with a chamfering tool, but it's not really necessary for what this is going to be doing. A lot of people forget you can use a file for simple operations like that. That was quite nice. There are no nasty sharp corners. Right. bought some of the machine second hand. It has got one or two what people call witness marks, or where some clumsy bastard's gone through with a cutter and damaged the bed. You keep wait every now and again, every so often, basically before I start a new job, I give the bed a quick clean. I have an oil stone here which I use only for this particular job. All it does, it takes any high edges off any little ding marks that may be on the bed. You're not actually going to take any metal off. You could rub this for the rest. You could rub this for the rest of your life and you wouldn't go anywhere. But it will take off any little high spots. If it's really bad, you can use a block of steel and a bit of, say, 1200 wet and dry. I've seen some machines that bad you could use an angle grinder on them. I think that's all it takes, just freshens it up a little bit. There's a couple of milling cutter marks there and there's some drill marks there. They all know when I got the machine. It doesn't make any difference, it just doesn't look very nice. I've got the headstand on two 1, 2, 3 blocks. It would have been simple if I made the mount it the other way around in the mill, but it's better this way to get the camera shots I want. That's going to be going on there. 2 cap heads through there, and then our bolt, and then our pin will go into there. What I need to do is make sure that this face here is parallel with the table on the machine, and we can drill and tap 2 holes in there, mark that one, and I'll probably bore that and ream it in the lathe. So the first thing to do is make sure this is lying square to the machine bed, then we'll get it clamped down. It's a quick way to get it very, very near, and then I'll show you how I clock it in after that. We need to make sure that the head is lying at 90 degrees to the table of the machine. One way to get very near, simply put a set square on there. It's touching all the way down the blade, so that's going to be a very good starting point. We'll clamp it at that and then use a clock gauge along that face to get it absolutely right. I'll show the same thing but from a different angle. I'm simply resting the square along the back edge of the T slot and then bring it across until the hands in the way. Bring it across until it touches all the way up the face, which is there, and that's going to be very, very near. I've got a couple of T-bolts clamping it down. Bear in mind, I'm only going to drill and tap 2 5mm holes. I'm not going to plough the front face of it, so just need to hold it, that's all. That's all it'll need. I'll put a clock gauge in here and clock that face just to make sure the face is running true. This is a simple little adapter on the clock gauge, something I use all the time. I've got the spindle on the milling machine locked. All you do, bring it across the touches, bring it to a 0 just for the sake of it, and we'll wind our table across. We're getting no fluctuation. That was the back of the gauge touching the clamp bolt. We'll do it again. On to 0. And that's pretty good. That was just simply setting it up with a set square. Had it been out, I could have moved it slightly to get it right, but it is running right. That's our pin coming through. The block's going to be mounted there. So what I want to do, I want to keep it level with the edge, the top corner there. And our bolt holes need to be down below that line. I'll put a packing piece in here, bit of high speed steel, just so I can clamp that. If that's clamped to that plate which is running parallel or at 90 degrees to the axis of the machine, and we can drill and tap our toe holes in there. That doesn't affect the locking device in any way. I'll put a clamp on there and then we can measure the centre of that, put our toe holes in. When I say a clamp, that's the sort of clamp I mean, a machinist clamp, not a G clamp that a welder uses. Same that I do use G clamps on the milling machine as well, but these clamps here grip parallel. That's nicely down. So now we need to find the centre of this, drill and tap and countersink toe holes. I've been speaking to a lad called Brian Warwick via email. Brian's busy putting a DRO onto his lathe, and he was wondering what sort of DRO I had, and I gave him my contact number at AMS International, and he must have looked after him because he asked us if I wanted a machine light he had going spare, which obviously I do because I need to put a new light on my little tool grinder. Anyway, Brian sent us this. It's a low voltage machine light, quite a nice one. I think it's 25 volt, but I'm going to convert it to 12 volt and use halogen car headlights. In Brian's package there was also 2 cups. Excellent for the workshop. I assume that one's mine. And this one here is going to be for Deb's. Anyway, Brian, thanks very much. Thanks for the light, thanks for the cups, and I hope you get on well with your DRO. Feed it towards the wiggler, and you'll see it flip off line. 0 the x-axis at that. Right. The end of that is 100 thou, half that's 50. So if we move the jog that way 50 thou, that'll put right on the edge. $50 thou. That's 750, 3/4. Half of 750 is 375. We can 0 that. 1, 2, 3. 750. So that now should be right in the centre. We'll lock the table up. It is right in the middle. Right, so our first point is going to be 3,750 from that end, and in the centre. That's 3/4 inch thick, 750, so we need to go down that far to get into the casting. And I'm going to go 1/2 inch into the casting, so that's 1 1/4 inch altogether. Just touch it off, which is there. You see with the Z axis, and we'll use that. So we want 750 first. This is a tapping drill for 5mm. That's 750, as you start to see cast iron coming out of it now. That's the cast iron dust coming out. That's 1 inch. Two, 1.25. Right, that's 1 1/4 inch. Right, now we've got a 5mm drill in, which is the clearance drill. Touch it off. That is to go in for 750. We can now use that 5mm drill hole as a pilot for a 5mm tap. That's a 5mm tap, it can't do anything else but go in straight. My favourite tap wrench, the one I made at school 40 years ago, and I'm still using it. I keep saying you never use a milling cutter in a drill chuck. This is the one of the many times you'll see me do it. Right, we need to go down 200 thou. Once again we'll touch it off. there, 0, Z-axis, 200. I'm going to need to shorten these bolts slightly now. Well, probably will. Yeah, it's bottomed out there, so we need to shorten the bolts. They always look better when the head of the bolt's being recessed. Those are bolts a better length. Slightly smaller head, but it'll not matter. And he's marking and the hole drilled and reaming through there, and then we're ready to index basically. Do it out quite nicely. I think I'll chamfer those edges right way around there on the milling machine, just the R sharp edges, and my hand will be playing around there. I've softened one of those 6mm dowel pins and machined the point on the end so I can use that as a punch, a transfer punch, to put a mark on there